Students, today we are going to introduce dynamic routing protocols. In the previous classes, we introduced routing protocols, focusing on static routing protocols and default routing protocols. We know that each static routing entry requires manual configuration by engineers, which can be quite challenging to implement in medium to large networks. Today, we will introduce dynamic routing protocols, where routing entries are formed through automatic learning. These protocols are commonly used in medium to large networks. What is a dynamic routing protocol? Let's look at the topology diagram below. There are three routers, R1, R2, and R3. R1 is connected to the 10.0.0.0.0 network and the 20.0.0.0 network. R2 is connected to the 20.0.0.0 network and the 30.0.0.0 network. R3 is connected to the 30.0.0.0 network and the 40.0.0.0 network. Now, let's take a look at R2's routing table. After configuring the interface IP addresses on R2, what does the router's routing table contain? As we learned from the previous routing protocol classes, after configuring the interface IP addresses on R2, two directly connected route entries will appear in R2's routing table. These entries represent the 20.0.0.0 network connected to the F0 port, and the 30.0.0.0 network connected to the F0 first port. The metric value in the routing table represents how many hops the network segment must go through to reach R2. In other words, how many routers it goes through. Since these routes are directly connected, their metric values are 0. If we want to configure a static routing protocol on R2, how to realize it? The directly connected networks are already in the routing table, so we don't need to perform any configuration. We need to add routes for the unknown networks 10.0.0.0 and 40.0.0.0 manually. We can use the following commands: IP route 10.0.0.0.255.0.0.0 next hop 10.0.0.1 IP route 40.0.0.0.255.0.0.0 next hop 30.0.0.2. If we use a dynamic routing protocol, we don't need to manually write the routes. The routers can learn from each other automatically. R2 will send its directly connected route information. My routing table includes 20.0.0.0 and 30.0.0.0 to R1 and R3. R1 will send its directly connected route information for the 10.0.0.0 and 20.0.0.0 networks to R2, and R3 will send its directly connected route information for the 30.0.0.0 and 40.0.0.0 networks to R2. Now, at this point, router R2 has learned the network segments of the entire network. There are various methods for R2 to learn the networks 10.0.0.0 and 40.0.0.0. We will use to represent these methods for now. Different routing protocols may have different metric values. Let's assume that the R3 router adds a new network segment, 50.0.0.0. R3 will send the updated routing information for the 30.0.0.0, 40.0.0.0, and 50.0.0.0 networks to R2. At this moment, router R2 can respond promptly to the changes in the topology by adding a route entry for the 50.0.0.0 network segment to its routing table. The above is the principle and demonstration process of dynamic routing protocols automatic learning. Now, let's learn how to theoretically describe dynamic routing protocols. What is dynamic routing? In a network, routers communicate with each other, exchanging routing information, and using the received routing information to update and maintain routing tables. This process is known as dynamic routing. Dynamic routing is implemented based on some routing protocols. It has the following two characteristics. 1. Reducing management tasks, making it more convenient for administrators to configure routing entries. 2. However, it increases the computation involved in data exchange between routers, thereby occupying network bandwidth. The dynamic routing protocol exchanges routing information with other routers, receives routing information from other routers, calculates the optimal path to each destination network based on the received routing information, and generates routing tables accordingly. It also promptly adjusts the routing tables in response to changes in the network topology, and announces the topology changes to other routers. We classify dynamic routing protocols based on the algorithms we employ to execute them. One type we refer to as distance vector routing protocols, and the second type we refer to as link state routing protocols. Firstly, let's introduce the distance vector routing protocol. Routers using the distance vector routing protocol send their routing tables to neighbors at specific time intervals. The distance represents how far a network segment is, and the vector indicates from which direction the network segment was learned. In the topology below, assuming router R2 can reach router R with a distance of 5, R2 will convey this information to R1. At this point, R1 knows that it can reach router R through R2, but R1 is not aware of the specific details between R2 and R. Next, let's introduce the link state routing protocol. Looking at the topology structure, originally, each router only knows the link state information of the links directly connected to it by obtaining information from peer routers, a complete network map. The link state database is established. As a result, each router in the network has a complete link state database. Based on the link state database, the SPF shortest path first algorithm is used to calculate a tree-like structure rooted at each router, forming the routing table. Here is the content of our class for today. Please complete the following assignment through your learning. 1. What are the differences between dynamic routing protocols and static routing protocols? 2. What is distance vector routing protocol? What is link state routing protocol? What are the similarities and differences between these two protocols?